Ladies and gentlemen, good morning. I'm Lai Yaxin from the Department of Endocrinology and Metabolism, the first affiliated hospital of China Medical University. Today, we are going to learn the definition and classification of Cushing syndrome. What is Cushing syndrome? It is a condition caused by prolonged exposure to excessive level of cortisol, usually from the overproduction by the adrenal glands, leads to the constellation of symptoms and physical features. Sometimes Cushing syndrome may be combined with increased androgen and aldosterone secretion. Cushing syndrome was first reported in 1912 by Dr. Harvey Willis Cushing. He was a neurosurgeon at Harvard University, and he reported the first case. It was a female patient who suffered from pituitary tumor and has menstrual disturbance. And after operation, the lady returned to normal state. So Cushing syndrome is nominated as Cushing syndrome in memory of Dr. Harvey Willis Cushing. In order to learn this disease, it is necessary for us to review some knowledge of the anatomy and histology of the adrenal gland. You can see this is the adrenal gland, and the outer part is the cortex, and the inner part is the medulla. Medulla secretes catecholamines, and the cortex is divided into three regions. The outer part is zona glomerulosa, which secretes aldosterone, and the inner part is zona reticularis, which secretes adrenal androgen, and the inner part in the middle, it is zona fasciculata, which secretes cortisol. Since we have learned Cushing syndrome is caused by overproduction of cortisol, so the larynx is on the zona fasciculata. And it is also necessary for us to review the normal hypothalamus pituitary adrenal axis regulation, and I've got a video for us, and I've got a video for you to watch. Please look at this video.
Welcome to 2-Minute Neuroscience, where I simplistically explain neuroscience topics in 2 minutes or less. In this installment, I will discuss the HPA axis. The hypothalamic pituitary adrenal, or HPA axis, is best known for its role in our body's natural reaction to stress. The HPA axis includes a group of hormone-secreting glands from the nervous and endocrine systems. The hypothalamus is a small neuroendocrine structure situated just above the brainstem that controls the release of hormones from the pituitary gland, a hormone-secreting gland that sits just below the hypothalamus. The pituitary gland can release hormones into the bloodstream that travel down to the kidneys and influence the secretion of hormones from endocrine glands called the adrenal glands, which sit on top of the kidneys. The primary function of the HPA axis is to regulate the stress response. When we experience something stressful, the hypothalamus releases a hormone called corticotropin-releasing hormone, or CRH. CRH signals the pituitary gland to secrete a hormone called adrenocorticotropic hormone, or ACTH, into the bloodstream. ACTH travels down to the adrenal glands where it prompts the release of different hormones from different parts of the adrenal glands. It causes the secretion of a class of steroid hormones called glucocorticoids from the cortex or outer layer of the adrenal glands. One of these glucocorticoids is cortisol, which plays an important role in the stress response. ACTH also triggers the secretion of epinephrine and norepinephrine from the adrenal medulla, which is the center of the adrenal glands. Epinephrine and norepinephrine are substances that act as hormones and neurotransmitters. When released from the adrenal glands, they act as hormones. The release of cortisol causes a number of changes that help the body to deal with stress. For example, it helps to mobilize energy like glucose so the body has enough energy to cope with a prolonged stressor. Norepinephrine and epinephrine act to keep the body vigilant and able to deal with the stressor by promoting alertness, and by increasing blood flow to skeletal muscles to ensure they are ready to act. When cortisol levels in the blood get high, this is sensed by receptors in areas of the brain like the hypothalamus, which leads to the shutting off of the stress response through what is known as a negative feedback mechanism.
And now I will explain to you the classification of Cushing syndrome. You can see this is the normal hypothalamus pituitary regulation, and hypothalamus secretes CRH, which acts on the pituitary and causes pituitary to secrete ACTH. Then ACTH acts on adrenal cortex and causes cortisol secretion. And when the cortisol is enough, it will tell the hypothalamus and the pituitary to inhibit the secretion of CRH as well as ACTH, and we call this regulation negative feedback. And the classification of Cushing syndrome includes ACTH-dependent Cushing syndrome, which include Cushing's disease, which accounts for over 70% of Cushing syndrome, and maybe tumor or hyperplasia of the pituitary. And ectopic ACTH syndrome, another one is ectopic CRH syndrome. It is very rare. And we also have another kind of Cushing syndrome, ACTH-independent Cushing syndrome, which includes adenoadenoma, adenocarcinoma, bilateral micronodular hyperplasia, and bilateral macronodular hyperplasia. And now I will explain them to you one by one. First, Cushing's disease. It is the most common type of Cushing syndrome, and it is a kind of ACTH-dependent Cushing syndrome. In this kind of patient, you can see the pituitary has tumor or hyperplasia and cause ACTH elevation, and then the adrenal cortex will secrete more cortisol. Another kind of ACTH-dependent Cushing syndrome is ectopic ACTH syndrome. In this kind of patient, it is usually caused by malignant tumor such as lung cancer. For example, the cancer secretes ACTH and cause the elevation in the plasma ACTH level, and the elevated ACTH will act on adrenal cortex and cause cortisol secretion. For ACTH-independent Cushing syndrome, we know that the lesion is on the adrenal cortex. It may be adrenal adenoma, adenocarcinoma, bilateral micronodular hyperplasia, or bilateral micronodular hyperplasia. In this kind of patient, the adrenal cortex will secrete more cortisol, and the elevated cortisol level will in turn inhibit ACTH secretion. So in this kind of Cushing syndrome, the ACTH level is low. And that's all for this lesson. Thank you for listening.